Substrate inhibition in bioreactors. Substrate inhibition in bioreactors occurs when the concentration of substrates such as glucose, salts, or phenols exceeds the optimal parameters and reduces the growth rate of the cells within the bioreactor. This is often confused with substrate limitation, which describes environments in which cell growth is limited due to a low substrate. Limited conditions can be modeled with the Monod equation. However, the Monod equation is no longer suitable in substrate inhibiting conditions. A Monod deviation, such as the Haldane-Andrew equation, is more suitable for substrate inhibiting conditions. These cell growth models are analogous to equations that describe enzyme kinetics, although unlike enzyme kinetics parameters, cell growth parameters are generally empirically estimated. General principles. Cell growth in bioreactors depends on a wide range of environmental and physiological conditions, such as substrate concentration. With regards to bioreactor cell growth, substrate refers to the nutrients that the cells consume and is contained within the bioreactor medium. Cell growth can either be substrate limited or inhibited depending on whether the substrate concentration is too low or too high, respectively. The Monod equation accurately describes limiting conditions, but substrate inhibition models are more complex. Substrate inhibition occurs when the rate of microbial growth lessens due to a high concentration of substrate. Higher substrate concentrations are usually caused by osmotic issues, viscosity, or inefficient oxygen transport. By slowly adding substrate into the medium, fed batch bioreactor systems can help alleviate substrate inhibition. Substrate inhibition is also closely related to enzyme kinetics, which is commonly modeled by the Michaelis-Menten equation. If an enzyme that is part of a rate-limiting step of microbial growth is substrate inhibited, then the cell growth will be inhibited in the same manner. However, the mechanisms are often more complex, and parameters for a model equation need to be estimated from experimental data. Additionally, information on inhibitory effects caused by mixtures of compounds is limited because most studies have been performed with single substrate systems. Types of inhibition. Enzyme kinetics overview. Cell growth in bioreactors. Overcoming substrate inhibition in bioreactors. Substrate inhibition can be characterized by a high substrate concentration and decreased growth rate, resulting in decreased bioreactor outputs. The most common solution is to change the growth from a batch process to a fed batch process. Other methods to overcome substrate inhibition include the addition of another substrate type in order to develop alternative metabolic pathways, immobilizing the cells or increasing the biomass concentration. Utilizing fed batch. A fed batch process is the most common way to decrease the effects of substrate inhibition. Fed batch processes are characterized by the continuous addition of bioreactor media, which includes the substrate into the inoculum cellular solution. The addition of media will increase the overall volume within the reactor along with substrate and other growth materials. A fed batch process will also have an output flow rate of the substrate/cell/product mixture, which can be collected to retrieve the desired product. Fed batch is a good way to overcome substrate inhibition because the amount of substrate can be changed at various points in the growth process. This allows for the bioreactor technician to provide the cells with the amount of substrate they need rather than providing them too much or too little. Other methods to overcome substrate inhibition include the use of two-phase partitioning bioreactors, the immobilization of cells, and increasing the biomass concentration in the bioreactor. Two-phase partitioning bioreactors are able to reduce the aqueous phase substrate concentration by storing substrate in an alternative phase, which can be re-released into the biomass based on metabolic demand. The cell immobilization method. The bioreactor works by encapsulating the cells into a material that makes the removal of inhibitory compounds easier, thus reducing inhibition by creating a matrix with the cells which can act as a protective barrier against the inhibitory effects of toxic materials. The method of increasing cell concentration is done by supporting the cellular material on a scaffold to create a biofilm. Biofilms allow for extremely high cell concentrations while preventing the overgrowth of inhibitory substrates. Impact on product production. The impact of product production depends on how the product is created. Substrate inhibition will affect products produced by enzymatic reactions differently than growth-associated product formation. Substrate inhibition of enzymatic product production will inhibit the enzyme's activity, which will lower the reaction rate and reduce the rate of product formation. However, if a product is being produced by cells, then substrate inhibition will narrow product formation by limiting the growth of cells. Growth-associated products.